good morning. So the next topic is servo motor. So we know what is servo motor and where we are using this servo motor. Where we are using this servo motor. This is the application of servo motors. It can be used in remote controlled cars, that DVD player, automation industries, that is where we are using the robotics, where automatic doors, automatic sliding doors, where we are using the malls, supermarket, etc. Then mechanical tools. Then the labeling of the packages, automatic packaging, automatic labeling, automatic spilling, the automation industry. So there we are using this servo motor. So the servo image, what is the meaning of servo? Servo. The servo is called and control unit. The servo means and control unit, which can be used in the closed loop system. Which can be used in the closed loop system. You know what is closed loop system? What is the difference between the open loop system and the closed loop system? The main difference between the open loop and closed loop. Okay. For which one we are having the feedback? For closed loop, we are having the feedback system. And open loop, no feedback. So what is the advantage of this having the feedback or not having the feedback? What is the advantage? What is the advantage? No idea? Losses. Right? So, okay, we'll see. So, here the servo motor can be operated in either linear motion or it may be a rotary motion. The servo motor can be operated in linear motion as well as in terms of rotary motion. Already we see which motor it can be operated in linear motion. Linear induction motor. The linear induction motor can be operated in a linear mode, but the servo motor can be operated in a linear mode as well as rotary mode. Okay, that is the main advantage of this servo motor. And the major advantage, the servo motor, it has very high starting torque. The servo motor, it has the very high starting torque. Already we see the repulsion motor. The repulsion motor is also having the high starting torque. But the servo motor is also having, at the time of starting, the servo motor is also having the high starting torque, because the shaft of the servo motor is very, very small. Okay, so that it requires less inertia. It requires less inertia, so that the torque is much more important. It requires only small amount. Okay, so it is easily to rotate the shaft in a smoother manner. Yeah, so that the starting torque is very high in a servo motor. That's the main advantage. So first advantage, it can be operated in a linear as well as rotary motion, and the second advantage is starting torque is very high. The starting torque is very high. And the third one, it cannot be operated in a continuous rotation. It cannot be operated in a continuous rotation, like in a stepper motor. In stepper motor, the rotor will rotate step by step. It will be rotating a step by step. But here it is not like that, but it is not used for the continuous operation or continuous rotation. Like I want to seal the packet, so there will be an automation machine will be there, it punches and return back. Again, another part will be there, it punches and it will return back. So whether it is a continuous, it will operate and it will hold on. Again, it will operate and it will be hold on. So like that it will be operating. It is not a continuous one. It is not a continuous. It can be operated with the rotary motion or linear. Okay, but it is not a continuous. So the main thing, the servo motor is mainly operated with the help of pulse width modulation technique. Which one? Pulse width modulation technique. So we know what is pulse width modulation technique. We will study the power power harmonics and drives. You know what is the pulse width, what is the difference between the sinusoidal pulse width modulation, trapezoidal, and there are 3 or 4 techniques will be there. You will see what is the pulse width modulation technique. Okay, now, so the pulse width modulation technique is a module which generates the control signal. It generates the control signal. So this is the load. This is the load. Now, what is our objective? What is our aim? So I want to control the speed. I want to control the speed. I want to stop the motor. I want to stop the rotor at this particular point. Now you can take an automated which train which introduced in the Chennai automation train. Which one? Metro. They are implemented now. Automatic metro they are implemented in the Chennai and some other place. Yeah. So the human being will not be involved in operating the trains. Am I right? So how the train will accurately stop at this particular junction? There will be a station will be there. It may be central or it may be Hindi or whatever it may be. There is no human being will be involved in to operate the train. But the train will stop at this particular point. Am I right? So it may be every day many trains will be there. All the train will be stopped at this particular point. How? This is because of the closed loop system. This is because of the closed loop system. So in a closed loop, so the load that will be operated with the help of a DC motor or maybe an AC motor. If you are using the DC, that is called a DC servo motor. If you are using the AC supply, that is called AC servo motor. So the load can be operated by using this motor. Now I want to sense the speed and position of the rotor. I want to sense what is the actual speed of the motor and where is the position. Where is the position? Now the rotor is facing here or the rotor is facing here. I want to sense the position also. That can be done by the position sensor. That can be done by the position sensor. So the position sensor is detect what is the actual speed. What is the actual speed and what is the exact position. Now I am expecting the position is like this. The speed is like this and position is like that. So the rotor is gets rotated. Once the rotated, the rotor exactly faces like this. Suppose the actual rotor, if the position is like this or like this, so the position sensor will detect whether the actual position is whether below the expected value or after the expected value. So the actual position should be like this. Expected position should be like this. But at the time of sensing the position sensor, the actual position it will be deviated. It will be deviated from the expected position. Maybe like this or maybe here or one. So we have to sense the position. So now the sensed position that will be given into the comparator. That will be given into the comparator. So already from the comparator, we are giving the certain control signal. That is our expected value. That is called an reference one. That is nothing but a reference signal will be given here. So now we are the reference. I am expecting with the angle of 10 degrees. The rotor position is 10 degree, but the actual position is 7 degree. Now the comparator comparing the reference input as well as the actual input which is sensed from the position sensor. Now the comparator comparing the 3 degree is variable. The difference is 3 degree. That 3 degree it will be given into the error amplifier. The 3 degree is given into the error amplifier. So the error amplifier, because the difference is 3. The 3 is very small value which is not sufficient to drive the motor. The error signal 3 is very small, which is not sufficient to drive the motor. So we have to increase the gain, we have to increase the power, and we have to increase the voltage of this error signal. Error signal over here, voltage and power has to be amplified, and we have to increase the voltage and power. That signal is given into the motor. So based on that error signal, the motor gets again operating. So now again it will be operated, and again we are measuring the angle of 9 degree. Again the difference is 1. Again it will be operating. So until both the reference and actual value should be same. Until it will be operating. So now the expected value is 10 degree. The actual position of the rotor is also 10 degree. So the output of the comparator will be 0. That means the actual position and expected position everything is same. So that's it. So like that it will be always sensing, always sensing the speed as well as the position of the rotor. Okay, now, so that's the main aim of the servo motor. Okay, now, so it can be used in the super automatic sliding door, in super motor, railway station, automatic relay ignition, all automation. In all purposes, we are using this servo motor. So the main principle behind this servo motor is nothing but pulse width modulation technique. It generates the control signal. The control signal can be generated with the help of this pulse width modulation technique. So this is the schematic diagram. So this is nothing but a rotor. In the rotor, it has a two input. One is nothing but a reference. One is nothing but a reference, and the other one is a control signal. So the control signal which is received from the position sensor. Okay, so based on the interaction of this control signal and the reference signal, the rotor will rotate in order to align with the actual position. Okay, so that is the concept of servo motor. In fact, it having the height starting. Okay, any doubt is there?